Hello students, this is Mr. Low. Today I'm going to give you a short lesson on this section called intermolecular forces of attraction. Now, as the name implies, intermolecular forces of attraction means it's between molecules. So in short, we're just going to call it INF, intermolecular forces. There are three of them: hydrogen bond, permanent dipole-dipole, we call it PDD, instantaneous dipole-induced dipole, we call it IDID. So these are the three intermolecular forces. Let's look at the first type of intermolecular forces, hydrogen bond. Hydrogen bond is found between two molecules. So on each of the molecule, it must satisfy one condition. On the first molecule, it must satisfy condition number one. Now, what is condition number one? Condition number one, you need to see a H atom attached to a highly electronegative atom of either F or N. For example, you must see a NH, a OH, or FH. So this is condition number one. Now, condition number two must be seen on the second molecule. On the second molecule, one of the atom must be a F, O, or N. Now, F by default has three lone pair, O has two, and N has one. So you need to have these three elements, either one of them present, for them to have their lone pair. So hydrogen bond will look something like this. Molecule number one, satisfying condition number one, you see a H attached to N. So on the N, you put a partial negative. On the H, you put a partial positive. On the second molecule, it must satisfy the second condition. Second condition, I see an N here with a lone pair. So when the delta plus H attracts the lone pair, this is termed hydrogen bond. So students, when you look for intermolecular forces, always look for hydrogen bond first. How do you know whether molecules possess hydrogen bonds or not? Number one, you see whether you can see an NH bond, an OH bond, or FH bond. Number two, on the second molecule, look for a lone pair that must come from either the N, O, or F. So that's the first one. Now, if no hydrogen bond is present, then you look for PDD or IDID. Now, PDD is found between polar molecules. On the other hand, IDID is found between non-polar molecules. So which comes to this part. Do you know how to differentiate polar from non-polar molecules? Okay, I know a lot of you got this issue. So today, I'm going to give you 4 simple rules to decide whether a molecule is polar or non-polar. Okay. Now, rule number one, hydrocarbon. Hydrocarbon means you contain only carbon and hydrogen. Carbon and hydrogen, their electronegativity difference is very, very small. They're actually very close. So you can consider carbon and hydrogen as two similar atoms. Molecules containing identical atoms, for example, Br2S8, they are all non-polar. So hydrocarbons and molecules containing identical atoms, they are non-polar straight away. So rule number one. Now, rule number two is the one I'm going to use very often. The focus is on the central atom. About your central atom, if you have zero lone pair, you have only bond pair, and all the terminal atoms are the same, the molecule is not polar. However, if one of the terminal atoms is different, then the molecule is polar. Okay, what do I mean by that? I'm going to give you a few examples on the board, so please take a look. Okay, now let's go to the first example, carbon dioxide. Carbon dioxide looks like this. So surrounding the central atom carbon, you have two bond pair, zero lone pair. And if you look at the side atoms, which are the O, they are all the same. So CO2 is non-polar. Okay, so this is the first example. Okay, another example, CCl4. So now again, my central atom is my carbon. Here, I have 4 bond pair, 0 lone pair. And if you look at the side atoms, they are all the same as Cl. So again, this molecule is non-polar. Get it? I'll give you another one. CHCl3. The central atom here is my carbon again. So this carbon has 4 bond pair, 0 lone pair. But this time round, if you take a look, this atom is different from this tree. So overall, this molecule is polar. Understand? So rule number 2 is the one that I'm going to use very often. So it goes like this again. Around your central atom, if you have no lone pair and only bond pair, and all the terminal atom, terminal means the side, they are the same, your molecule is not polar. But if one of the terminal atom is different, the molecule turns out to be polar. So rule number 2. Okay, rule number 3. Again, about your central atom, if you have one lone pair, for example, ammonia, there's one lone pair on the end, for sure the molecule is polar. Okay, why so? If you have one lone pair, your molecules will adopt a certain shape, so much so that the dipoles cannot cancel out. So therefore, you'll be polar. Okay? If you have 2 bond pairs and above about a central atom, now the molecules may or may not be polar depending on the shape. So you have to see whether the dipoles can cancel out or not. Okay, let me give you another example. Okay, take a look at what. Water molecule surrounding your O here. I have 2 bond pair, 2 lone pair. Water is a band shape. On the O, you have a partial negative. On the H, you have a partial positive. We draw a dipole from the delta plus n to the delta minus n. So these are the 2 dipoles. Now, if your dipoles look like this, they can cancel out. But if your dipoles look like this, you know they cannot cancel out. So for water, the dipoles cannot cancel out because it's a band shape. So water is a polar molecule. Yeah? Okay, let's make this one. Xenon tetrafluoride, XeF4. So surrounding your xenon, you have 4 bond pair, 2 lone pair. This guy has what we call a square planar shape. Xenon, delta plus, F, delta minus. So see, this dipole and this dipole will cancel out. This one and this one will cancel out. So overall, this molecule is non-polar. Why so? Because the net dipoles is equal to 0. They cancel each other. Good? So these are 4 simple rules that you can follow to decide if a molecule is polar or non-polar. So ultimately, if a molecule is polar, they will possess PDD. If a molecule is non-polar, they will possess IDID. Good? So in conclusion, students, IDID is seen mainly in non-polar molecules. Now, in fact, all molecules have IDID. Okay? It's just that it's seen mainly in non-polar molecules, that's all. Polar molecules have PDD. If you have PDD, you will also have IDID. Because IDID is like the basic forces all molecules possess. If you have hydrogen bond, you will have all 3 types of intermolecular forces. And of these 3 INF, hydrogen bond is the strongest, followed by PDD, followed by IDID. But this is only valid if and only if the MR of the compounds must be approximately the same. Because if the MR has a vast difference, sometimes you will see IDID can even be stronger than H bond. Yeah? Okay, so this is all I have for you today. A very short lesson. Hope you have learned something. Okay, goodbye. Take care.